bulb lights when current flows. There's a battery. Here's a screw. Screw is a conductor. Ooh, a bit of metal to conduct. So you've got the wire. Clips onto the screw. This one clips onto the screw. Clips onto the battery. So we've got the positive and negative shit together. Yo. Now this is the light. So this is the thing we're trying to get power to. The battery supplies the power to the light. We don't really need this red shit, do we? You take this red one away, move this yellow one onto it, and you save yourself a screw and a wire. Conducting an experiment. This circuit can be used in an experiment to find out which materials are good conductors of electricity. Like a plastic lobster. A plastic lobster, a wooden peg. Well, I suppose you could use that metal bit on the wooden peg, that little clip they've got there. A key, a pair of scissors, a bit of foil, whatever that is, a napkin, something on the napkin. A battery is a device that uses a type of energy called chemical energy to produce electricity. Chemical changes take place inside the battery to produce tiny particles called electrons. The battery acts like a pump, pushing electrons around a circuit. When the battery is connected in a circuit, the electrons are pushed out of the negative terminal around the circuit and back to the other end, called the positive terminal. Positive terminal. More drink. Positive terminal. So positive plus negative terminal, negative minus. Electrons produced by chemical reaction move around the circuit. So it comes out of the negative. The positive. So it comes out of the negative, it goes back through the positive. Simple batteries like the one you use in torches or cameras are called cells. Okay, cells. The perfect cell. Inside most light bulbs is a very thin piece of metal wire called a filament. When an electric current flows through the filament, it warms up so much that it glows white hot. It is the brightly glowing filament that produces that light that we see. In a light bulb, much of the energy supplied by the electric current is wasted as heat. On the move. Electric current flows through one contact on through the filament and out through the other contact. And if you've seen the bulb that's gone out, you'll see the little filament become a little dangly thing. Most circuits include a switch. A switch has two metal contacts that can be held apart or together. When the contacts touch, the switch closes and electric current can flow around the circuit. When the contacts are held apart, the switch is open and current cannot flow. Without switches to open the contacts, electrical devices like lights would be on all the time. So that's good. Spring separates the contacts when the switch is opened. Metal contact connected wire. Make a connection. When the switch is closed, electric current can flow through it. I see. So this little thing here is what does the connection. This is connected up to this. And then this thing here. That's the light switch. So that's how the light switch works. It pushes the metal down. Light switch is off. Light switch is off. And then you turn it on and it pushes this shit down so it touches. Good, I'm learning some shit. Anything on the car? You put a stupid car here, you can't even click on the thing. This is there for decoration. The bin. What's in the bin? Oh, look at the state of that. These swans are not happy. Or maybe they are. Natural resources are the things we take from the environment to make the products we use in everyday life. For example, we drill oil from the ground to make petrol, cut down trees to build houses, kill animals to eat their meat. The Earth does not have an infinite amount of natural resources for people to use. Unless we are careful, our natural resources may eventually run out. Destroying habitats using natural resources can produce waste products that damage the environment. Then the swans eat them. You cut open the swan's belly and see a load of plastic shit in the swan. Then you eat it at the Chinese. The world's natural resources are running low, so it is very important to recycle things. Recycling allows us to use things again that we used to throw away as rubbish. Without recycling, the Earth will run out of the natural resources we need to make the things we use in everyday life. Some plastics, paper, metal, glass can now be recycled. To make new cans. Aha! Crushed cans. Aha! Into a block. Aha! Melted down. Haha! Press flat. Haha! And new cans. The circle of life here. Oh, yes. We get the can, we crush the can, we squash the can, we melt the can, we flatten the can, we make a can, so on. Recycling. Most metal objects can be recycled. Most glass can be too, but first it must be sorted by colour. What? You're going to melt the whole fucking shit. It's going to become a fucking silvery lump of flattened fucking toilet roll. And it's going to be sorted by colour? What the fuck? It says most glass. I mean, it's talking about fucking glass. The glass is going to become a molten pile of shit as well. What bloody difference does it make? Well, if you're worried about fucking prettiness, I'm sure you could make glass out of whatever fucking colours you get. You have to be picky about colours. The skeleton is a strong framework that holds the body up and gives it shape and support. It is made up of more than 200 bones linked together by joints. There are joints at the shoulders, knees, toes, all over the body. Your bones also protect delicate parts of your body, such as your heart, lungs, brain. Many of your bones have muscles attached to them to help you move. Skull, shoulder bone, rib cage, arm bone, spine, pelvis, hand bone, knee joint, leg bone, foot bone. There are over 600 muscles in your body. Almost every move you make, from raising an eyebrow to kicking a ball, is caused by muscles pulling on bones to make you move. Other muscles work deep inside your body, helping you breathe, making your heart beat, digesting your food. When you exercise or move fast, your muscles have to work much harder than normal. Ugh, muscles. Breathe. Breathe again, Con. Breathe. Breathe. What breathing I've got? I can't breathe. I've got a fucking stuffed up nose. So what happens then? Your ribs move out. I don't think so. Maybe. Well, I suppose maybe if you got all your skin missing, your ribs might do that, but I don't think with all the muscle in the way and all that shit. I can feel that bone, that top bone there. I don't see it rise as high as this thing goes. Look at that. Ooh. I don't think it goes like that. I think it rises a little bit. Your respiratory system enables you to breathe. Your main respiratory organs are your lungs, which are found in your chest. You breathe to get oxygen from the air into your ribcage expands, your diaphragm flattens, your air rushes in to fill your lungs. When you breathe out, your chest muscles relax, your diaphragm rises, the air is pushed out again. Diaphragm flattens. How do these people breathe? Your diaphragm rises, not flattens. What if you breathe through your diaphragm? I was supposed to breathe through your diaphragm, sing through your diaphragm, all that crap. Your lungs are found in your chest and are protected by your ribs. When you breathe in, you suck air down your windpipe or trachea into your lungs. Inside your lungs there are millions of tiny air sacs called alveoli. Alveoli, maybe. Your blood collects oxygen from the air inside that alveoli and carries it to the rest of your body. Windpipe, bronchi, left lung, right lung. Next. All the time, your heart is pumping blood around your body through tubes called blood vessels. There are two types of blood vessels, veins and arteries. Blood travels out of your heart through arteries and into your heart through veins. As your blood flows, it carries vital food and oxygen to every part of your body and collects harmful wastes. Your heart and your blood vessels together are known as your circulatory system. Veins, heart, arteries. The red ones are the arteries then. Arteries. That's an interesting little diagram. So the arteries are like a little human shape. Oh wait, no, like a little... Looks like that bit of ginger I had in that drink. I mean the ginseng. Sort of. Little ginseng. Your heart is an organ about the size of a fist. It is made of muscles which squeeze and relax to pump blood around your body. Your heart has 4 spaces called chambers with valves that open and close to make sure the blood flows the right way through them. Valves. Chambers. You could live in those little chambers. Maybe. Probably not. Make a house shaped like a heart.
It sends blood surging through your body. With each beat, blood enters your heart through the upper chambers and flows down into the lower chambers.
Through the upper?
When the lower chambers are full of blood, they squeeze inward to push the blood out of your heart. As this happens, the 2 valves between the upper and lower chambers close to stop the blood going the wrong way. As the blood leaves your heart, a second set of valves slam shut to stop any blood flowing back.
These animations are much better than the other lessons. I mean, the English and maths lessons. These animations and talking go well together. They're interesting. If they made a whole game about this, got rid of Woody, it wouldn't be too bad. Your heart beats about once every second. With each beat, blood flows into your heart through the upper chambers, down into the lower chambers, and is then pumped out to your lungs and the rest of your body. The sound of your heart beating is made as the valves inside your heart slam shut. You can hear this sound clearly through a special instrument called a stethoscope. Or, if they did a little animation to go along with the speaking in the other lessons, like English, like highlighted words for the English and something, and for the maths, just showed numbers pop up, 2 times this is this, and all that shit. Made little animations to go with it. But most importantly, got rid of Woody. Could have been a good game. Good educational game. But no. It's average-ish. Slightly below average because of Woody. Your blood is constantly flowing around your body. Blood is made up of different kinds of cells floating in a watery liquid called plasma. Your blood has a vital job to do. It carries oxygen and food to cells all over your body. It also collects harmful wastes and takes them away for disposal. It helps your body fight against germs and diseases. Plasma, white blood cell, red blood cell, platelet. What's a platelet? Will it tell me? Probably not.
Your circulatory system is made up of 2 loops. The first loop collects oxygen from your lungs, and the second loop supplies this oxygen to the rest of your body. Blood travels first from your heart to your lungs along the pulmonary artery. This artery leads to a network of capillaries inside your lungs, where oxygen is collected by the blood. The capillaries are connected to the pulmonary vein, which then carries this oxygen-rich blood back to your heart. In the second part of the circulatory system, blood travels from your heart to all the other parts of your body. The blood leaves your heart through the main artery, called the aorta. This artery divides into a network of capillaries. Blood passing through the capillaries supplies oxygen to all parts of your body. The oxygen-poor blood then returns to your heart along the main vein, the vena cava, before beginning its journey again.
That's interesting. A little loop. Okay, blood travels around your body in a cycle. Your heart pumps blood out along vessels called arteries to your lungs, where oxygen is picked up. Blood then returns to your heart through your veins and is pumped to the rest of your body, where it is delivers oxygen and food before it finally returns to the heart to be pumped around all over again. Vena cava, okay, pulmonary veins there, lungs, pulmonary artery, aorta, heart, vena cava, and capillaries. Right, and have your garden this summer. Sit in nursery for the best variety of flowering plants. Inside a flower. Many plants grow flowers in order to reproduce them. The parts used to make seeds are found in the middle of a flower. These are often surrounded by large, colourful petals which help to attract animal visitors, such as butterflies, bees, birds. These animals play an important role in the reproduction of plants because they aid pollination. Stigma, stamen, pollen, petal, lily flower. A lily flower lures pollinating insects with bright petals and richly perfumed scents. Ooh, pollinates me. Oh, flowering plants produced by growing flowers and making seeds. There are over 250,000 kinds of flowering plants, and they can be found everywhere from busy roadsides to the Earth's most remote places. Some of these plants grow flower and die in the space of a few weeks, but others can live for more than 1,000 years. A flowering plant. To aid pollination, flowers often grow at the stem tips. Pollination. Before a plant can make seeds, its flowers usually have to be pollinated. During pollination, a yellow powder called pollen travels from the male parts of one flower to the female parts of another flower. Some plants use the wind to carry their pollen, but many use visiting animals such as birds, insects. They pay their visitors with a meal of sugary nectar. Bird pollination. This unusual kind of hummingbird has a curved beak that fits in their long, thin flowers. Ooh, make a hummingbird straw. Seeds. All flowering plants grow from seeds. A seed is a package of living cells protected by a tough outer coat. It contains the beginnings of a plant called an embryo and a supply of food to help the embryo to grow. A seed can stay like this for months or years, but when it gets outside of right, it suddenly begins to grow in flowering plants. Seeds form inside fruits. Honesty seeds. These grow inside dry, coin-shaped fruits. Each seed is round and flat, the seed's coat. What the hell is a coin-shaped fruit? These grow in a coin-shaped fruit? What fucking fruit is that? Coin-shaped? I don't remember any coin-shaped fruit. Coin-shaped fruits. Anyway, that's interesting about a seed is a package of living cells. I guess that's why they're so good for you. A package of living cells. A fruit is a seed container that grows from a pollinated flower. It protects the developing seeds until they are spread by animals or the wind to grow into new plants. Fruits can contain just one seed or more than 1 million. Some fruits are soft, juicy, good to eat, but others are hard, dry, and inedible. Poppy. A poppy seed head is a typical dry fruit. It scatters seeds when it is shaken by the wind. Those are poppies. I've seen those before. The opium flower. It's been 42 minutes. See how much we've done.
Let's see how many less...
Be quiet, you. I was happy to be away from you. 12. We are not hardly anywhere done for that. Probably going to take another 2 hours, possibly. 2 hours to do that. That's not too boring, I suppose. So does it leave me at the same spot? Of course it doesn't. Put me back there, you bastard. Don't know what it says you are here for. He's just gonna move me back, the stupid bastard. Oh shit, look at all that in there. Load of shit in there. Load of shit everywhere. I did that. Air resistance, friction. I never did that, did I? I remember the radiator of the Earth, but air resistance, friction. I don't remember that. It's hidden somewhere. Where's this air resistance, friction shit? Or is it out here? Where's this air resistance shit? It's not the plane, is it? That's the stupid radiator. There's the clock. What's this air resistance bullshit? Fucking idiots can't program a game right. It's probably the...
I know.
So look, in that little room, we've got air resistance, friction. If it's not inside that room, let's have a look outside. This thing. What's this shit? This leads to outside. The bat. Ah, there it is, the air resistance shit. Air resistance is a form of friction that acts on objects moving through the air. When a car moves, the air around it slows it down. Cars that have rounded or streamlined shapes can pass through the air more easily. It is important for car designers to think about air resistance, as a streamlined car uses less fuel than one that is not. Comparing cars. Modern cars have streamlined shapes which help them to move through the air. Modern streamlined car. Old-fashioned car. If you push and let go of a cardboard box, it will move. However, the force of friction soon slow it down and bring it to a stop. Friction acts between any surfaces that rub together. There is more friction between rough surfaces than smooth ones. If there were no friction between shoes and the floor, you would slip over and not be able to walk or run. Designed to grip, trainers have ridged rubber soles to increase friction. Haha. I did that. Where's the other thing? Why has it even got a view for this thing if you can't click on it? We've got water pollution. Where? Or is that on the outside? Well, there's friction. I'm actually here. I can't even do the fucking map properly, so I'm guessing that goes there. Oil. The oil's in the right place. Or the only thing in the right place, that oil. Did I do pollution? I think I did. Oil. I mean oil. There's more oil. Oil. Even more oil. Birds. 2 virus bacteria. I don't think they spent much time on this. Half-assed it. Most of it in the wrong place, and some of the names are the same. There's 2 things. Look, there's now food eating there. There's food eating here. Well, I've done 13, so that's something. But that's enough for the moment. Good riddance, Woody.